Hello friends, I am Kshitij Batham and in today's lecture we are going to study motion in a straight line part 4th. Part 1st, 2nd, 3rd has already been covered in separate videos. Okay, so this is part of chapter number 3 CBSE NCERT physics book for class 11th. Okay, so before we start, I would like to request one and all to subscribe to our YouTube channel and click on the bell icon to receive the future notifications. Okay, so we will start with kinematic equations for uniformly accelerated motion. Okay, so there are three kinematic equations for uniformly accelerated motion, that is namely first equation, second equation and third equation. So we will start with first equation of motion and we will prove it by using calculus. This is also called velocity time relationship. Okay, so we have already studied that instantaneous acceleration is defined as rate of change of velocity with time, or A is equal to dB by dt. This is called as instantaneous acceleration. So when we will cross multiply, we will get dv is equal to a dt. We will get dB is equal to a dt. So after that, after getting dB is equal to a dt, we will integrate both sides with limits. We have to integrate with limits. Okay, so we will integrate left hand side with limits u to v and right hand side with limits 0 to t. U is the initial velocity at time t is equal to 0 and v is the final velocity at time t is equal to t. Okay, so we have already covered the concept of integration during our lectures on mathematical tools. Okay, so on integrating you will get v minus u is equal to at. Integration we have already covered. Okay, so by rearranging you will get v is equal to u plus at. This is the equation of motion. This is first equation of motion or velocity time relationship and we have derived it by using calculus. Okay, so now we will move to second equation of motion. Okay, so second equation of motion, okay, so it is also called position time relationship. Okay, so now we know that instantaneous velocity is rate of change of position with time. So rate of change of displacement or rate of change of position with time gives us instantaneous velocity. So we get v is equal to ds by dt. Okay, so again we will cross multiply. So we will get ds is equal to v dt. So we have already proved that v is equal to u plus at. This is the first equation of motion. Okay, so v is equal to u plus at, put in this equation ds is equal to v dt, put v is equal to u plus at. You will get ds is equal to u plus at dt. So by simplifying you will get ds is equal to u dt plus at dt. This is what you will get. Okay, ds is equal to u dt plus at dt. So again you will integrate on both sides with the limits. Okay, so as we know that position will change from 0 to s, time will change from 0 to t. Okay, so we can integrate with limits. For ds on the left hand side we will use limits 0 to s. At t is equal to 0 distance travelled is 0 and t is equal to t distance travelled is s. Okay, so we will integrate on both sides with limits. Okay, and we have already covered integration in our previous topics. So what you will get, s is equal to ut plus half at square. This is second equation of motion or kinematic equation for uniformly accelerated motion number 2. S is equal to ut plus half at square. It is also called position time relationship. Okay, now we will move to third equation of motion and we will prove it by using calculus. Okay, so how will you prove third equation of motion? It's a bit tricky. So we know that instantaneous acceleration is given by a is equal to dv by dt, rate of change of velocity with time. So you will multiply and divide by ds by ds. You will multiply by ds and divide by ds. It will have no impact on A is equal to dB by dt. And then you will rearrange. You will take ds by dt together. Okay. So you will get, you know that ds by dt is equal to v. ds by dt is equal to v. So you will get A is equal to v dB by ds. Okay, so now you will cross multiply. You know that A is equal to v dB by ds. When you will cross multiply, you will get A ds is equal to v dB. You will get A ds is equal to v dB. Now position is changing from 0 to s and velocity is changing from u to b. That means at time t is equal to 0, velocity is u, and at time t is equal to t, velocity is v, and at time t is equal to 0, distance traveled is 0, distance or displacement, and at time t is equal to t, displacement is s. Okay, so you will get, you will integrate on both the sides with required limits. You will get as is equal to b square minus u square by 2, and by rearranging you will get b square is equal to u square plus 2as. Okay, b square is equal to u square plus 2as. This is the third kinematic equation for uniformly accelerated motion. So we have proved all the three equations of motion by calculus. So now we will move to our next topic, that is distance traveled in ns second or n second. So we know that distance traveled in n second is given by s is equal to ut plus half at square. But there is difference between distance traveled in n second and distance traveled in nth second. There is difference between distance traveled in n seconds and distance traveled in nth second. Distance traveled in n second means total distance traveled from 0 to n. Time t is equal to 0 and time t is equal to n. How much distance has been traveled, and distance traveled in nth second, what does it mean? Between at particularly at nth second, how much distance is traveled. How will you calculate distance traveled in nth second? You will calculate by using the common sense. Common sense tells us distance traveled in nth second will be distance traveled in n second minus distance traveled in n minus 1 second. That means total distance traveled in n second minus distance traveled in n minus 1 second, that will give us distance traveled in nth second. Okay, so we know that distance traveled in n second is given by un plus half an square, and distance traveled in n minus 1 second is given by un minus 1 plus 1 by 2 a n minus 1 square. Okay, directly we are putting t is equal to n and t is equal to n minus 1 in second equation of motion. So we will get these two equations. Now you need to solve it. Okay, so now you will simplify it. Okay, un plus half an square minus ka un plus u minus ka half a n minus 1 square. Further solve it further. Use a minus b whole square is equal to a square minus 2ab plus b square. Further simplifying, we will get this, and finally we will get distance traveled in nth second is given by u plus half a to n minus 1. This is distance traveled in nth second. Okay, distance traveled in nth second is given by u plus half a to n minus 1. Okay, that's all for today. Thank you for watching. See you soon in our next video. Thank you.